Hello, this is Dr. Frost. Just before we begin, just to note that you can practice questions interactively on this topic, including past paper questions, just by going to www.drfrostmaths.com/homework. Feel free to pause the video at any time, whether just to digest the new material or whether to do one of the test your understanding questions that I'll be setting you throughout the video. Now let's begin. This is the first of a series of videos on curved graphs. We're going to look how to plot curved graphs today. We'll look how to sketch quadratics, and I'll explain later in another video what's the difference between plotting and sketching. We'll be looking at the sort of form of different graphs, such as like cubics, exponential graphs, etc., and various algebraic problems to do with curved graphs. Now, plotting a graph is basically just getting a table of values, so different values of x, working out what the y is for each value of x using some kind of equation that dictates the graph, and then we're just going to draw some axes, and then we're going to plot these various points on there and join them up with a nice curve. And we're going to specifically plot curved graphs, not say straight lines. So let's look at this first example here. We want to complete the table of values for y equals 6 over x. And basically, this is like a rule, a membership rule, that says whether a point belongs on that line. So any point that is on the line with this equation has to obey this particular rule. So the y value has to be equal to 6 over whatever the x value is. So usually in a GCSE question, they filled out most of the values for you. So we just have to work out the y values for each of those x values here. So let's do this. So when x is equal to 0.5, that's a half, isn't it? When x is at 0.5, what is y going to be? Well, y is going to be 6 divided by 0.5. Now, the easiest way to do this, well, there's two different ways of doing this. When you do a division, you're asking how many times does 0.5 go into 6? Well, how many times does half go into 6? Well, half goes into 1 once. There's two halves in 1. So half must go into 6 12 times. So it's just going to be 12, isn't it? Yeah? So it's going to be 12 there. We want to also find when x is 3. So when x is 3, we have y equals 6. Sorry, y equals 6 over 3, which is 2. And then finally, when x is 5, we've got y is equal to 6 over x, which in this case is 5. And if you had a calculator on you, you'd realise that's 1.2 as a decimal. Right, so now we hence want to plot y equals 6 over x for x between 0 and 6. Now often in new GCSE papers, they kind of give you a sort of blank axis, and you might have to work out appropriate scale to put on it. So what we generally do is we look at what range of x values we have, where it goes from, we want it between 0 and 6, and also the y values as well. So we've got y, the maximum value was 12, and we can see the minimum value out of all of these, the y values, is 1. Now usually you would have a copy of this table and you can actually draw on this. But we can see the maximum is 12, the minimum is 1. So I'm going to do appropriate graph. Got this. And they're all positive as well. I'm going to put the x values on first, so it goes between 0 and 6. So that's, say, 6 here. Let's just make sure we've got appropriate amount of space. 1, 2, 3, 4, 5, 6. Making sure when you choose your scale on your axis that it's going up by the same amount each time, in this case 1, and making sure that they're evenly spaced as well. Those are the two important things. Now we know the y value has to go up to 12, so I'm just going to do up to 15. So why don't I do, or even 20 even, so got 5, 10, 15, and 20. Now usually you would have square paper for this, or graph paper. And we have to plot on here. And again, we make sure these are evenly spaced, they're 5 apart, and they're evenly spaced in terms of the distance between them. It's roughly evenly spaced. This is just slightly approximate. The other thing to mention is that usually numbers either go up in 1s, or in 2s, or in 5s. You wouldn't choose some kind of random number to go up in. So we wouldn't go up in 3s, for example. It's generally 1s, 2s, 5s, or 10s, 20s, 50s, etc. So let's plot this. We've got 1. When x was 0.5, y was 12. We had that over here. So 0.5, 12. So we've got it here, roughly there. When x was 1, y was 6. So we have it here. Yep, that'll do. When x is 2, y is 3. So 2, 3, which is about there, so you can see 3 roughly here. When x is 3, we worked out y was 2. So about here. When x is 4, y is 1.5. So we can see these are getting progressively small. So it's getting lower and lower and lower. And then what you do, once you've got these points, we can see this sort of forms a curve. So we don't want to join these up kind of like straight lines between them, because if you think about what this is going to look like, the line that goes between them, it's probably not going to be jagged edges, is it? It's a curved graph. And then let's join these up. So making sure you go through the points. Generally, they allow mark schemes a kind of millimetre tolerance, so your line can't go more than 1 millimetre away from the particular point. So it's going up like this, and we can see, well, we can guess sort of what's going to happen, but basically it's going to shoot up like this. Yeah? And notice, by the way, that let's just say x was 0. What's 6 divided by 0? Well, you can't actually do it. And it's basically what's happening to the value is it's shooting off towards infinity. Because if you had, for example, say 6 divided by 0.1, how many times does 0.1 go into 6? Well, 0.1 goes into 1 10 times. It must be 60. So it's going to be a really high value. When x is 0.1, y will be 60. And you can see it's sort of shooting off towards infinity. And this is an example of something called a reciprocal graph, but we'll see the category of these graphs in the next video. We're just going to be looking at how to plot these things today. So let's go on to the second one. I've picked an example of each type of graph. That was the reciprocal graph. This one is called a quadratic graph, and the reason is because there's a kind of x squared term and then possibly an x term and what we call a constant term. The constant term is a term in this equation which doesn't have an x on it. So if the highest power in this is 2, it's known as a quadratic equation. I'm going to sketch this here, this quadratic graph. Right, so let's find out the missing values first. So when x is equal to -4. Now be very, very careful when you substitute -4 into this equation. So if I do this very, very carefully, y equals -4 squared plus 2 times -4. I'll explain why I've used the brackets in a second. -3. So if you're ever substituting negative values into an expression, always make sure that you put the negative value in the bracket. And the reason is if you're on your calculator, you were to do -4 squared, and you didn't use the bracket, well, what would we expect to get? Well, what's -4 squared? -4 times -4. Well, we know negative times negative is positive, so we expect to get positive 16. But if you write -4 squared on your calculator, it actually gives you -16 rather than positive 16. So what happened there? The problem is basically bidness. When your calculator sees -4 squared without the brackets, if I write over here, if I wrote -4 squared like this, what your calculator is doing is it's doing the power first, so it's doing 4 squared first, which is 16, and then it's doing minus that, so -16. Because if you think about bidness, the indice comes before like subtraction, for example, or negation. So it's doing the 4 squared first, then negating it, when actually you want to do the -4 first and then square that, which is why we need to use these brackets. Now we simplify this. We could put it on our calculator, so we could write in brackets -4 squared plus 2 times -4, again using the brackets, -3, and that will give us 5. But it is also legitimate to do this in your head. So -4 squared, we know, is 16. And then 2 times -4, so if we write this separately, if we wrote the working, we got 16 plus 2 times -4. 2 times -4 is -8. So we're adding -8, which is the same as subtracting 8. And then we finally got -3, and we could have got it that way as well. Now let's do it for the remaining values. These ones are easier because they're now 0 or positive. So when x is equal to 0, y is equal to 0 squared, so we're substituting it in again, 0 squared plus 2 times 0, -3, well, we can just do this one in our head. 0 squared is 0, 2 times 0 is 0, and then subtract 3, we get -3. And then finally, when x is equal to 1, we get y equals 1 squared plus 2 times 1 minus 3, and that is equal to 1 plus 2 is 3, minus 3 is 0. So we get that. Now I'm just going to write this table of values again. Now there's a very good reason for it, because we're going to see a certain pattern here. So what have we got? We've got minus 4, minus 3, minus 2, minus 1, 0, 1, 2. And what values have we got? When x was minus 4, we had 5. And then minus 3 was 0. Then we had minus 3, minus 4. 0 gave us minus 3. 1 gave us 0. And then 2 gives us 5. Now we'll see if we can see a pattern with these numbers in a second, but let's sketch it first. So I'm going to do appropriate axis again. Now let's see what x goes between. X has got to go between minus 4 and 2. And on the y-axis we're going between, well, the lowest value is minus 4 and it's going up to 5. So let's do the x-axis first. So it's going between minus 4 and 2. So if I put the axes here first, the y-axis, minus 4 and 2, if I make that 1, 2, so that's going up to 2, down to minus 4. And then let's do the y-axis now. So it's going between minus 4 and 5. So I can just have 1 per unit here. So we've got minus 1, minus 2, minus 3, minus 4. And we're going up to 5. So 1, 2, 3, 4, 5. And just about enough space to put my y in there. Yep, right, now let's just plot it. So minus 4, 5. So minus 4, 5 is up here. Minus 4, 5. We got minus 3, 0. So on the x-axis, minus 3. And then the y value 0, so we don't go up at all. When x is minus 2, so minus 2 on here, minus 3 on the y-axis. Make sure you get your x and y the right way around. When we've got x is 0, we've got, when we've got minus 1, y is minus 4, so we have down here. Then when x is 0, y is minus 3, so 0, minus 3. When x is 1, y is 0, so it's here. And then when x is 2, y is 5, so we're back up here. Now again, we need to use a smooth curve, and what can I advise when you try and draw this? Avoid doing like a sketchy line like that. You don't want to do it in bits. You want one nice continuous line. Now you don't have to do it all in one go, but you want to try and get a smooth continuous line like this. Yeah, making sure you go exactly through the points. It's down there, and then up, up, up. Now, you can see I'm doing it in bits, but I'm still getting a nice, smooth, continuous line. And we can see we get this U shape again. And there will be a separate video on specifically how we can sketch quadratic equations. And you'll see they either have this kind of U shape or smiley face shape, as is often said by teachers, or a kind of frowny face shape with this kind of hill shape like that. And we'll see under what conditions we get smiley face or frowny face, depending on what equation we're sketching. So we get this shape. Now, why did I want us to write this table of values again? Can you spot the pattern of these numbers? Well, firstly, spot some property of this graphic. Can you see it's symmetrical about that line? And because it's symmetrical, the y values will also be symmetrical. So we've got a y value of minus 4 here, and then either side we've got a y value of minus 3, here we've got a y value of 0, and here we've got a y value of 5. So you can see in the table of y values here, we can see it's symmetrical about that minus 4. We've got minus 3, we've got 0, and then we've got 5. And that's really helpful to observe, because whenever you're sketching, plotting a quadratic equation, we know that the table of values has to be symmetrical. The y values have to be symmetrical. And that will help you when you do this test your understanding question later, because you can sort of work out what some of the values are just by the symmetry of the values. Now let's go on to the third example here. This one is known as a cubic equation, because the highest power of x is 3. It's x cubed, so therefore it's known as a cubic. And again, we'll see in a future video like how you kind of plot cubic graphs and the kind of properties of those. Well, with sketching cubic graphs, sorry. So I'm just going to copy the table this time because most of our values are missing. We've got x, y, so we've got -2, -1, 0, 1, 2, 3. And we're going to use this equation. So we've got the -1, haven't we? We've got 8. Now the hardest one is the -2, so I'm going to try and do it without a calculator. We've got when x is -2, and then we've got y is equal to x cubed, so -2 in brackets, because it's a negative value, cubed, and then we've got minus 3 times in brackets -2, close brackets, squared, plus 12. And then let's work out what each of these values are. Well, -2 cubed is -2 times -2 times -2. Well, -2 times -2 is positive 4, because negative times negative is positive. And then 4 times another -2 gets us to -8, because positive times negative is negative. So we get -8. In general, a negative number cubed is always a negative number. Now, this one's really hard in terms of making sure we evaluate this correctly. Firstly, let's just do the -2 squared. So we've got -2 squared is -2 times -2 is positive 4. And then we've got 3 times that positive 4, which is 12, but then we're subtracting 12. So it's going to be -12 here. And then finally, we've got that plus 12 at the end. So the -12 plus 12 is going to cancel, so we're just left with -8. So let's put -8 in here. Now it gets easier because, well, these are all positive, and putting 0 in is generally quite easy. So if we've got, 0 cubed 0 cubed is 0. 3 times 0 squared is still 0, and then we're plussing 12, so that's just going to be 12. What about 1? I'm just going to do my working this time, because this one is hard to do in your head. When x is 1, we've got y is 1 cubed minus 3 times 1 squared, plus 12, and, well, we can do this in our head probably. 3 times 1 squared is just 3, so 1 minus 3 is -2. -2 plus 12 is going to be positive 10, so let's put that in there. And then what about when x is 2? We get y is equal to 2 cubed minus 3 times 2 squared, plus 12, and that is equal to 8. 2 squared is 4. 4 times 3 is 12, so we're minusing 12, and then plus 12, and then basically we get 8 again, don't we? Yep. And then finally, so let's put the 8 in there. And finally, when x is equal to 3, I'm trying to save space here, so I've enough space for the graph. Y is equal to 3 cubed minus 3 times 3 squared plus 12. And that's just going to be equal to, that's 27 minus 27, that's just cancels, plus 12 is 12. So we get the 12 here. Right, let's now sketch it. So appropriate axis again. Well, the y-axis is going between -8 and 12, and then the x-axis is going between -2 and 3. So we can put this roughly in the centre. Let's use as much space as we can. And let's put in the x values first. So we're going to go up to 3. And we're going down to -2. So -1, -2. And then let's get the y values between -8 and 12. Now I've got to pick an appropriate axis here, appropriate scale, sorry. So I'm just going to do, for simplicity, I'm going to do go up to 15. So I'm going to go up in 5 this time. So 5, 10, 15, just making appropriate use of the space there. And then we're going to go down to -10. So -5 and then -10. Now let's plot these. So we've got -2, -8. So -2, -8 is roughly down here, but you would have graph paper. minus 1, 8. So minus 1, positive 8, which is roughly up here. Then we've got 0, 12. So 0, 12 is here. And then we've got 1, 10. So 1, 10. And we've got 2, 8. So 2, 8 is roughly like this. And then finally 3, 12. So 3, 12, it's going back up again. 3, 12 is roughly like this. Yep. And again, we need to join these up with a smooth curved line. So we go through like that. It's going to come up, and then it's sort of coming down here. And you get that. Cool, so this is kind of like an uphill roller coaster shape, as I like to describe it. And again, in the next video, when we saw the different categories of graphs, we'll see like the different shapes that we typically get for different equations. Right, okay, next one. So this one is known as an exponential equation, and again we'll see the names of these things in the next video. And again, I'm just going to quickly copy out the table because there's quite a few values missing. So we've got minus 2, minus 1, 0, 1, 2, 3. So I'll put in the values we've already got. 0.25 is there, and the 1 is 2. So let's work these out. When x is equal to minus 1, y is equal to 2 to the power of minus 1. Now, hopefully you've done laws of indices before you've watched this video. If not, you might want to see the laws of indices video. But when you have a negative power, what it does is it basically does 1 over whatever you have, but without the negative power. So it's 2 to the minus 1. We do 1 over, and then we just do 2 to the 1 without that negative number. And what's 2 to the power of 1? Well, 2 to the power of 1 is just 2. So it's 1 over 2, i.e. 0.5. So I'm going to put the 0.5 in there. And then let's do the next value. When x is equal to 0, we've got y is equal to 2 to the power of 0. We're substituting in x for 0. And it's just something you need to know about laws of indices. But whenever you have a power of 0, you always get to 1. Well, there's one exception to that, but we won't go into that. So 2 to the power of 0 is equal to 1. So let's put 1 in there. Now we've already got this value. And then it gets easier because we get positive values. So when x is equal to 2, y is just equal to 2 to the power of 2, which is 4. And when x is 3, we get y is equal to 2 cubed, which is 8. And you can possibly spot the pattern with these numbers. Can you see that the numbers are doubling each time? So let's plot it again. So we've got x varies between minus 2 and 3, but notice the y values are positive. So in terms of the space that we're using, we can have the x-axis at the bottom. And it's going to go between, the y-axis still has to go in the middle though. So that's positive, so it's going to go up like this. That's y. And we can now put in our x values in. So we got our x scale. Minus 2, minus 1, and then 0, 1, 2, 3. And let's put in the y values now. So it's going, well, the lowest value is 0.25, and it's going up to 8. So I'm going to do it up in 2s. So 2, 4, 6, 8. Remember, any axis you have on a scale, we tend to like it to have going up in either in 1s or going up in 2s or in 5s or 10s or 20s or 50s, but not in 3s or 7s or anything like that. Right, let's plot the values. So minus 2, 0.25, so that's going to be quite low down. Minus 2, 0.25, just hovering above the x-axis. Minus 1, 0.5, so minus 1, 0.5, so that is 1, that's 2, that's 1, so that's 0.5 there. Then when x is 0, y is 1, so 0, 1, so exactly halfway up to that 2. Then when x is 1, we've got y is 2, so we've got that. And then when x is 2, we've got y is 4. And then when x is 3, y is 8. So we have up roughly about there. And again, let's kind of join these with a continuous line. Nice and neat and nice and smooth, and it goes like that. And in general, when you have an equation of the form y equals something, some number, some constant to the power of x, then you get this shape here. And that's known as an exponential graph. Now finally, we have this test your understanding question here. It's a quadratic equation again. And by the way, I didn't say earlier, but the name of the line itself is known as a parabola. So the posh name for the line, when it has a quadratic equation, is a parabola. So I want you to sketch this parabola. You've got this equation. You've just got a few missing values. So fill in those missing values in the way we've done before, just by substitution, and then choose appropriate scale for your axes, then draw a graph. So you may want to pause the video now to try that question. Right, hopefully you've had some time. So let's work out these values. I'm going to very quickly copy out this table of values. So we've got x, y. We got -1 up to 5. And we got 2, -1 already, -1, and that's 7. Yeah. Cool. Right, let's do when x is -1. So when x is equal to -1, y is equal to, so we've got x squared, so hopefully you did -1 in brackets squared, -4 times -1, and then +2. And then let's work out the bits of that. -1 squared, any negative number squared is always positive. Well, any number squared is always positive, so it's +1. 4 times -1 is -4, but then you're subtracting -4, so you're actually adding 4, and then +2, and you should have got, that's 5, 7, isn't it? 7. Now, and if you were particularly astute and remembered that there's a symmetry in a parabola, you could have seen, well, these two are -1, so those two must be 2, so I can fill in that 2, and then we could have got that 7 there because we know that's a 7. So that just leaves us with one value left to work out. So when x is equal to 2, y is equal to 2 squared, so 2 squared minus 4 times 2 plus 2, and that's equal to 4 minus 8 plus 2, and what's that equal to? 4 minus 8 is -4, plus 2 is -2. And we get -2 there. Right, now let's just plot it. So our x-axis goes through -1 and 5. The y-axis goes through -2 and 7. So let's put an appropriate x-axis here. And the y-axis we're going to put more to the left side because you can see it goes from -1 to 5, so 0. The next value of 0 is more like here. And really go up like this. Right, let's put the values in. So 1, 2, 3, 4, 5, and then we're going only to go down to -1 this time. And then the y values start from -2, and they've got to go up to 7. So I think this time I'm going to go up in 2s again. So 2, 4, sorry, that's not slightly evenly spaced. 6, 8, and we've got -2 and -4, not that we need to go that low. X, Y. So let's plot the values. -1, 7, so -1, 7 is here, 0, 2 is here, 1 minus 1 is here, 2 minus 2 is here, 3 minus 1 is here, 4, 2 is here, and 5, 7 is up here. So 5, 7, it's there. And again, let's just plot with a nice smooth curve. There's a certain wrist technique to this. Keep on going. And then join it up this way. And we get this rather beautiful parabola.